Hi, everybody. We're finally back after a long break, and we're going right back into the series. We're resuming with the chapter we left off, which is chapter 4 of IGCSE Maths, titled Collecting, Organizing, and Displaying Data. So, first off, we're going to look at what data actually is. Now, there are mainly two types of data, and as you can see what's written here, the two types of data are qualitative and quantitative data. Now, qualitative data is also known as categorical data, and quantitative data is also known as numerical data. So, what does this mean? Categorical data or qualitative data basically means data that cannot be represented by numbers. For example, if you ask someone what their hair color is, they cannot answer that with a number. They could answer red, they could answer black, they could answer blue, but that's not a numerical answer. Hence, what you just got by asking that question is qualitative data. Now, for quantitative data, you can imagine the exact opposite. Quantitative data is data that comes in numerical form. For example, if you ask someone, how many hours in a day do you spend watching TV? They would probably answer 2 hours, 3 hours, maybe 5 hours, and all that is numerical. They're giving you their answer in a number, and hence that makes it quantitative data. There are two types of quantitative data, discrete and continuous. What's the difference here? Discrete data is basically data that can only take certain values. For example, if you ask somebody, how many people attended the event? They can't answer 2.5 people. That doesn't exist. They can answer 3 people, they can answer 4 people, but basically they're restricted to the range of whole numbers and probably however many people the event venue can contain. So that is discrete data. Continuous data, on the other hand, is data that could take any value between two given values. For example, height or width. If you ask somebody for their height, they definitely will give you a numerical answer, but that value could be 165 centimeters, 165.5 centimeters. The possibilities are endless and they stretch on, so it's hard to distinguish what type of numerical answer they'll give. And that's continuous data, data that doesn't really get separated into categories. Now we're going to talk about collection methods. Depending on how you collect your data could become primary data or secondary data. So what's the difference here? The difference here is where you get your data from, the source of your data. Primary data is from primary sources. For example, if you were to carry out a questionnaire to ask people how many hours they spend in a library every week or every day, the responses you receive from all the questionnaires can be compiled into your primary data. Secondary data is data that you get from secondary sources. For example, the data you can get by reading books in the library, or the data you can get by researching on the internet. All of this is secondary data. So basically, all the information we receive from our textbook is also secondary data. Now we're going to look at organizing data. The first way to organize data is by using a tally table. And in the tally table, you will be seeing tally marks or also just a tally. So what is a tally? Have you perhaps seen this symbol around before? If you have, congratulations, you already know what a tally is. In case you're not familiar with it though, no problem. Let's do a little exercise. Before that, let's go over how we count in tallies. 1, 2, 3, 4 goes as we expect, but 5, we no longer continue like this. we go with a stroke through the middle. And this also basically just makes the grouping easier, so it's easier to count tallies in general. Um, you cannot get this wrong. This is the basic of tallies. Now, let's quickly fill up this table down here. We have three colors from the looks of it, of this diagram. We have red, blue, and green. So I'll just fill it up. Red. Let's change to a blue. Blue. And now let's get a green going. Green. Okay, so I'm just going to use a black pencil to quickly fill this up. How many reds do we have? We have 1, 2, 3, 4. We have 4 reds, so let's just do 1, 2, 3, 4. Blue, we have 1, 2, 3, 4, 5, 6 blues. So we're going with 1, 2, 3, 4, 5, 6. As for green, we have 1, 2. So we're going to do 2. 1, 2. That's how you do tally marks. As for the final column here, you might see the text below. This column is not required for a tally table. I just put it there so that I can show you that it totals up 4, 6, 2. But it is not necessary to include that column for a tally table. The tally table component is simply this part. Okay, now we're going to move to the next page. Here I have some exercises that I designed. You guys can pause the video to take it down to do the exercises later, or if you guys want to do it now, that's no problem as well. In case you can't read my handwriting, I'll just quickly read out the exercises for you. Exercise 1, construct a tally table for the following sample. Exercise 2, toss a coin 20 times. Construct a tally table for the results. For all of the answers to the exercises in this video, I will post a link in the description a day after release. So this video should be coming up on Wednesday Malaysian time. So the answers will be posted in the description box by Thursday Malaysia time. Now, if you're done with this exercise, we're going to move on to the next method, frequency tables. So frequency tables shows the totals of tally marks. And frequency is basically just how often an event or an object occurs. This is just a copy of the previous graph. Now, also to note is that the last column, if you were to include it just now, it would have been a frequency table, except for one point. We don't write number. What we write in this column is frequency. Now, frequency tables also typically do not include the tally column. This is just a carryover exercise from the previous example. That's why the tally table is in here. But if the question asks for a frequency table, you can construct it without the tally column, unless it prompts you to or it asks you to. Now, so we're just going to fill it in the same. Basically, we go with red, blue, green yet again. And for red, we have 4. So 1, 2, 3, 4. For blue, we have 6. 1, 2, 3, 4, 5, 6. And for green, we have 2. Fill it in here. 4, 6, 2. After we do this, however, there is one more aspect to frequency tables, and that is that you have to just add one more column. Let's just extend these. I'm just going to do a messy look of what you're supposed to be doing, but yeah, I don't know. Oh. Okay, so what are we writing here? What we're writing is the word total. Total, the tally marks, you can draw the total, sure, no problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then here you write 12. So that is a key point that you have to remember. So what makes a frequency table? The category, number 1, the frequency, number 2, and the total. So remember these three components. Moving on, now we're going to take a look at class intervals. What are class intervals? Now, a lot of data is difficult to group into individual numerical categories. For example, in this case, when you're asking someone to compile the data of test scores from a class of 100 students, it would be ridiculous to write 0 to 100 on the scores column. That would make an incredibly long table, and it'll be incredibly hard to analyze the data. Not to mention, there might be values where there are no students. In that case, it makes it kind of pointless to include it, but we still have to. Therefore, easy solution, class intervals. You just make categories, as you can see here, and then this is the frequency, the number of students that scored in that range. So for example, 42 students scored in the range of 41 to 60. And in total, there were 100 students, which matches up with the question, and hence this table is correct. Now let's take a look at exercise 3. Mary did a survey on her classmates. She asked each of her 40 classmates how many pencils they owned. These are her results. Construct a frequency table using appropriate class intervals. Again, answers will be posted in the description tomorrow. Now, we're going to be looking at two-way tables. What's a two-way table? It shows the frequency for two or more sets of data. Basically, it's the same as a frequency table. It's just that it shows more than one category. You guys probably already know how to construct these without even knowing. So the example here is the length of hair on a group of males and females. As you can see the numbers here, this shows that there were 12 bald males, there were 3 bald females, so on and so forth. Exercise 4. Michael recorded the following information at a library. 1. There were 34 men who entered throughout the day. 2. There were 41 women who entered throughout the day. 3. 16 men left with books. 4. 12 women left without books. Construct a table with the appropriate categories using the information. Now we are going to look at using charts to display data. Basically, charts. So number 1, we have pictograms, the simplest of charts. Kind of cute, kind of elementary, but they're a simple chart. It uses a key to represent quantities. As you can see here, 1 heart is 5 cookies. In box A, there are 3 hearts, so the total number of cookies in box A will be 3 times 5, which is 15. In box B, there will be 10 cookies. In box C, there will be 25 cookies. And in box D, only 5 cookies. I feel bad for whoever gets box D. Box C should share some of their cookies. Moving on, we have an exercise. Yes, you can make the key be divided into half and take a guess as to what value that would represent. Complete this exercise and the answers will be up soon. Oh yes, I'll read out the question. Exercise 5. 1 red circle is equal to 200 people. How many people is represented by each of the following? Exercise 6. Using the key and data, construct a pictogram. Shelf A, B, C, D, E, number of books, 12, 6, 15, 24, 9, and 1 black circle is equal to 6 books. The next type of graph is something called a bar chart. A bar chart is typically used to display discrete data. For example, the number of cars in the parking lot on a particular day. Yes, bar charts can go either direction. It really doesn't matter. What's important in a bar graph is that each axis is well labeled. with numbers that make sense. And of course, the width between bars should be the same. So what would be wrong is, for example, this is equal, then suddenly you have this bar over here, or suddenly this bar is over here. All that is wrong. You should make the spaces in between your bars as similar as possible. And in the case when you're using graphing paper, you would be able to make it identical. Even if you're not using graphing paper, just pull out a ruler to make sure that the gaps are equally distanced. As for the bars themselves, they should also have the same width. For example, all my bars, if you compare them, they are uniform. They have the same width. You shouldn't have one bar that's really skinny and one bar that's really thick. No. We need to have uniform bars. So what we need to remember here is that the y-axis is labeled, the x-axis is labeled, the bars are of equal width, and the gaps are of equal width. Also, I didn't label it here because the example up there is already the instruction. But if you draw a bar graph, it is best to label it. So in this case, you can just write number of cars in a parking lot on a particular day. There's also something called compound bar charts. And what it is basically a bar chart that displays two or more sets of data for ease of comparison. Don't mistake it for a histogram. I'll get into that later. But basically, by what you can see here, it still displays discrete data. There are two styles that you can choose from. Both of these are compound bar charts. As you can see here, I've written something. What's the problem? I'll give you 5 seconds. 5, 4, 3, 2, 1. If you're thinking it's something with the bars, that's wrong. The bars are fine. The problem here is that they didn't label your x-axis. We don't know what months we're looking at. This could be January, this could be February, this could be March. We don't know. And this is why, my friends, you have to label your x-axis. I can't label it for them because I don't know what months they're talking about. And for this bar chart, it's also similar. I mean, this bar chart doesn't have any issue. This is a correct bar chart. It just shows the comparison figures between male, female, and total UK resident population. So for an example, in 1959, the male population was 25,000, and then we have to add on the zeros here, so it's 25, so it's 25 million. So just now I mentioned the difference between histogram and bar charts. We will be touching on histograms in math, but it's not appearing in this chapter. But just to avoid confusion when you're doing exercises or when you're attempting certain past year questions, I'll be talking about the differences between a histogram and a bar chart. Here we have a bar chart and a histogram. This is a histogram and this is a bar chart. A histogram displays continuous data. So you can see here, all the bars are touching. This is not to be confused with a compound bar chart where you might have bars touching as well. They are not the same. This isn't data on a linear scale. This is data that's continuing. The frequency changes, but every single point is a data point. It's not in this case. This is very much based on category. So yes, we have the difference between a bar chart and a histogram. Now we have exercise 7. Draw bar charts for the following sets of data. A. Favorite food: burger, pasta, chicken, chips, other. Number of people: 40, 30, 84, 20, 29. B. Average scores on test and pretest. Pretest average, test average, Class A 65, 70, Class B 89, 87, Class C 76, 79, Class D 80, 81. Next up, we have pie charts, where all the data is given in percentages. Now, this is just a really cute one. Obviously, it doesn't reflect any actual data that's going on, but yes, this is a cute example. You can look through that. And the one thing that I need to teach you here is how to convert raw data into this pie chart. So we'll do part of the next exercise together. Exercise 8. Draw a pie chart for the following data. Number 1, how a student spends her day. So let's just take a random column. Let's go for sleep. This student gets 5 hours of sleep per day. So 5 out of 24. You can add it up to verify, but there's 24 hours in a day. So 5 out of 24, to get the percentage, you multiply that by 100%. And you are going to get around 20.8%. This is because you actually get 20.833333. It's a recurring decimal, so we're not going to deal with that. 20.8%. Now, that's great and all, but other than for labeling the pie chart, you can't do much with this value. How do you draw the pie chart? Easy. The pie chart is a circle. And how many degrees is there in a circle? 3, 2, 1, 360 degrees. So we just take this nice little fraction here and we multiply by 360 degrees. What is the value that we get? 75 degrees. This is the value that you're going to take. Use your protractor, measure out 75 degrees, and draw your pie chart. So do that for the rest of the data here, construct the pie charts, answers up tomorrow. Moving on to the final component, we have line graphs. And line graphs are used to show a trend or a relationship between two factors. Science students will probably know what I'm talking about. And the independent variable is always on the x-axis. Maybe some of you are thinking, what is an independent variable? Don't worry. In an experiment of any kind, a social experiment, a science experiment, or even day-to-day life, not necessarily even an experiment, just observing your environment, the factor that is being changed is the independent variable, and the factor that is getting affected is the dependent variable. For example, in the case of temperature of hot chocolate over time. Time is changing, and the temperature of the hot chocolate is getting affected by that. So as we can see here, as time goes on, the temperature of hot chocolate goes down. That is a very ugly arrow. The temperature of hot chocolate goes down. What we need to keep in mind is that for line graph and also every other type of graph, there has to be a title. There has to be a title for the bar chart, for the pie graph, for histograms, for line graphs. Every kind of graph needs a title. It needs to have its y-axis and its x-axis labeled. The intervals between your values must be consistent. Here, it cannot be, for example, if this is the x-axis, you cannot have 0, then 10, then 20. No, 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 no. No. Oh, but this, okay, this reminded me of something. There is one situation where your scale can look like this. A very specific situation. Your scale will never look like this. Okay, let me complete this mess. This is wrong. This is wrong. But there is one situation. I'm just gonna pull up a bit of blank space to show you what I'm talking about. So let's say we're observing the depth of water in a pond uh, over the course of a year, and we have the months down there. We won't look at the whole year because that would require a lot of graphing and probably graphing paper to do it accurately. But let's just label it. First of all, we have the title, depth of pond water. Then we have our y-axis, our x-axis. Why did I leave that gap? Now, the depth of water will never be 0, but let's say you want to label your axis here as 0. That's totally fine. But let's say the depth of water is, even at its lowest, 3 meters high. But you don't want to use the scale 3, 9, 12, because your data is more specific than that. Your line graph will end up being very narrow if you use that scale. You don't want to use that scale. The scale you want to use is in 1 by 1 intervals, as in 1, 2, 3, but you have no data here, so your chart also won't take up this space. It would just be up here. So how do we solve that? We want to start from 3, but we don't want our intervals to be 3 by 3. Simple. You do this pattern here. This shows that you've basically scrunched up the graph. There was something here, now there isn't. Then you put 3, and you continue on your day. Of course, I should also label my axis so you actually know what I'm talking about. This is depth of water in meters, and this is month. January, February, March, April. That was a big gap. April, May, June. So maybe it's here, 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 here. Okay, the thing about line graphs whilst you're attempting the exam question is, number one, whatever graph you plot must occupy at least 70% of the given space. So let's say if your graph is like this, minus mark. If your graph is like this, minus mark. You need to occupy at least 70% of the graph. So choose your scale wisely. Don't choose a scale where your data is all scrunched up and small by the side. Another thing, your lines need to be smooth. They can't be like this. No, it needs to be a smooth line. So use a ruler, and in the case where the graph is a curve, you can either buy those special curvy rulers, or you can just do what I did last time, which was bend my ruler and take like 5 minutes to draw the graph. It's less efficient, but at the same time, in my opinion, it's also easier. So good luck with that. And when you're plotting your graph, let's say this is the grid. So these are grids, right? You can use a dot or you can use an X. Your X or your cross, however, cannot be bigger than the size of a grid. So if you do something like this, wrong, you would get minus marks for that. So make sure it's kept small. And it may seem easy because I've drawn these so big, but they are so small in actual practice. Just take out a piece of graph paper and you know what I'm talking about. In other words, use the dot. It's honestly easier and safer. The X's get a bit large sometimes. So yes, that is how you construct a line graph and certain points that you need to remember whilst constructing a line graph. I hope you wrote those parts down because that's really important when it comes to the exam. It's a make or break kind of situation for those few marks. Okay, so that's basically it for this chapter. And what we're going to do now is that we're going to look at the chapter summary. What have we done this chapter? A lot of things. First, we looked into data. And in data, we learned that there is quantitative data and qualitative data. In quantitative data, we can further break it down to discrete data and continuous data. After going through that data, we talked about data collection. Under data collection, we have primary data and secondary data. Then we talked about ways to organize data. Organization. What types of organization methods were there? We had tally tables, we had frequency tables, we had class intervals, and we had two-way tables. After that, we had charts. And there were a lot of type of charts. There were bar charts. An extension of bar charts is compound bar charts. And then we had histograms, which we will touch more on later chapters. And there were a lot of type of charts. There were bar charts. An extension of bar charts is compound bar charts. And then we had histograms, which we will touch more on later chapters. We had pie charts, and then we had line charts. So go ahead and revise the notes for this chapter. Do the exercise questions. I'll be posting the answers to those questions tomorrow. And along with that, I'll also be posting the relevant past years for this topic tomorrow, along with the answers, of course. So there will be answers for the exercises in this video, and there will also be extra questions and the answers for them. After that, you can search through the past years on your own to attempt even more questions related to this topic, or you can wait for next week for the next topic to come out. Also, before you leave, we actually are recruiting right now. If you're interested in helping us to create more videos like this to help everyone study better, study smarter, actually to just study, please contact us. I'll try to put the email up on screen now, but if it's not here, then you can also head to our description box to email us, or you can head to our Instagram page and DM us there for more information about recruiting. With that said, I hope that this video has helped at least one person, and have a nice day.